Welcome to Taoyuan Hsinchu Miaoli Regional Branch. I've been working here for almost 30 years. I give trainings on residential ACs and also ACs for commercial, industrial, and medical use. However, for residential and commercial AC, it's difficult to find installation workers. In addition to labor shortage, we also have to deal with the shortage of skills. It's so hard to find people, even the unskilled workers may be hired. That can cause many problems. So we need to organize trainings for people to develop skills. Currently, we provide trainings for AC installation. Welcome to the branch to learn to install the ACs. The class is easy. You just need basic principles and hands-on practice. Then you can start. The video today will cover air conditioners or the HVAC. I'll cover its mechanism, the refrigerant, and the specifications. Students will learn to read nameplates. In the market, many disputes arise from installation. I will talk about installation and maintenance. First, the mechanism. It's simple. Let's start with two principles. The first one, how do gases turn into liquids? In our daily lives, you can see that when water vapor gets in contact with ice, for example, this glass of ice water, we see water drops on the outside. It's because when the water vapor meets cool air, it turns into liquid, gas into liquid. When we visit a tire shop, we will see an air compressor that measures the tire pressure. The owner regularly opens the water valve underneath. When water would come out, the air is sucked into the compressor. After the gas is pressurized, it turns into water. You can see when we try to turn gases into liquids, we can do so by cooling the air. We're increasing the pressure. You must be wondering, if we try both cooling and pressurizing, it's even better. If the pressure is high enough, I don't need to keep the temperature too low. The water doesn't have to be that cold to turn gas into liquid. What does this have to do with the refrigerating? You could see, when gas turns into liquid, the heat has to dissipate to enable the transformation. To better illustrate my idea, we will look at the refrigerant circulation system. The second principle, how does liquid turn into gas? To put it simply, here's the water. I boil the water to become vapor. By heating up the liquids, it will turn into gas. We've just explained that water absorbs heat and turns into vapor. Alternatively, you can reduce the pressure. You can see that there are some vacuum-packed food. The foods are not sun-dried or roasted. They were put in a space. When the pressure was lowered, if you vacuumize a space, the liquid inside will turn into gas. By sucking out the air, you will turn liquid into gas. Two methods. One is heating up. The other is to lower the pressure. It's even better to combine the two. At 50 degrees, liquid can turn into gas. It's like cooking in high altitude. It's not easy to boil. Pressure decreases with a higher altitude. If you want to turn liquids into gases, you will need a very high temperature. Try to understand how gases turn into liquids and liquids into gases. These changes are very common. The theory also applies to air conditioner. This air compressor sucks in the air. Loaded in the AC is not air, but refrigerants, which generates heat after compression. High pressure and temperature turn liquids into gases. After cooling down, after heat dissipation, the gas turns into liquid. To turn gas into liquid, you need to increase the pressure and reduce the temperature. Gas turn into liquid. After decompression, it becomes cooler. It might be difficult to understand, but let's look at an example. In an outdoor restaurant or an outdoor cater event in the summer, when it's too hot to eat outside, what do? They use mist machines. With the spraying of pressurized water, the temperature will drop. That means compressed liquid refrigerants. After decompressing and spraying, the refrigerants may become cooler. the temperature can be as low as minus 100 degrees, even 150 degrees. After the pressure decreases, the refrigerants become cooler and naturally absorbs heat, and they turn into gases. Let's get back to the compressor system. The two principles that we've just talked about are applied in an AC. This is a compressor. It pumps out the refrigerants, and the refrigerants turn into liquids in the condenser. And here the refrigerants are around 50 degrees, and the air is 35 degrees. The refrigerants release heat. So you can see the outdoor units of a split-type AC is installed on the outside. The units releases heat. When you walk along the corridor, you can feel the hot air coming from the outdoor units. The air is warm, and the heat comes from the compressing the refrigerants, and the wind outside blows it over, and that's the warm air we encounter when you walk along the shops. After compression and heat release, gas turns into liquid. The liquids pass through the capillary tube. This is made of copper. Liquid refrigerants pass here, and the temperature drops to 5 degrees instantly. This is how AC works. If it's refrigerating, the pressure is even lower, and the temperature will drop to minus 15, 20 degrees or even lower. The refrigerants here are liquids. The refrigerants flow in the copper tube at 5 degrees. The air is at 28 degrees and pass through heat exchanger at 5 degrees. And then the air enters a room at 18 degrees. This space is an air-conditioned space. This is the refrigerant circulation system. This is a split-type AC. There are 4 components in this type of AC. This is a compressor. Gas turned into liquids in a condenser. Then it's decompressed in the capillary tube. The refrigerant's temperature drops. Then the liquid refrigerants will evaporate. So this is the evaporator. And the refrigerants flow back to the compressor. You understand that refrigerating is simple. A compressor and condenser turn gas into liquid. There's also the decompressor, reducing the pressure of liquid refrigerants. Here, liquid refrigerants absorb heat, turning into gases and flow back to the compressor. Major components are compressor and condenser and evaporator. For industrial water chillers, large ones are up to 1,900 tons, or 500 or 600 tons. Or in a convenience store, there are some refrigerators that consist of the 4 major components with some variations, but the refrigerants used are different. The levels of pressure reduction are different, so the temperature are different too. Today focus is ACs. These are window ACs. These are window ACs. This is split type. This is the indoor unit, and this is the outdoor unit. The outdoor unit has compressor, condenser, and other parts. The evaporator is in the indoor unit. We've just covered the slides. Let's look at the real AC. I'll use a window AC as an example. This is a compressor. This is the exhaust tube of the compressor. Here comes compressed gas refrigerants. The refrigerants then flow through the condenser. And here, the temperature of the refrigerants ranges between 40 to 50 degrees, flowing in the pipeline. Fins are inserted here, connecting to the copper tube to increase the surface area of the copper tube. So dirty fins would compromise heat dissipation. Hot gas refrigerants pass through the air here. Air flows in from here and flows out from this way to the outdoor. The outdoor temperature in summer is 35 degrees. The temperature here must be higher than that. For instance, 50 degrees. Refrigerants at 50 degrees dissipate heat, and after it turns into liquid, which flows to this part, passing the capillary tube, which is very thin. After decompressing, the refrigerant's volume increases. The temperature of refrigerants here is 5 degrees. It's very cold, and the refrigerants pass through the copper pipeline. The temperature remains at 5 degrees. Refrigerants flow in here, and the indoor air flows in from here. Usually a filter is installed here. It needs to be cleaned regularly. The air passes through the filter and flows out. The temperature of inflow air is 28 degrees, for example, and drops to 15 to 18 degrees when the air flows out. In this way, it can cool the space. And in the summer, it won't be too hot. Let's look at the components: compressor, condenser, capillary tube, the decompressing device. And this is the evaporator with 4 components. Installation of a window AC is often restricted by space, so split AC units are actually more popular than window AC now. We've looked at window AC. The split AC has the same components. It has a compressor, which is connected to the condenser. The condenser leads to the capillary tube. And here, the refrigerant is cooled into liquid. Remember, this tube is called low-pressure liquid tube, which leads to the evaporator. Heat is absorbed here, with pressure reduced to create gas. Some AC technicians call this high-pressure tube, and the other low-pressure tube. That's wrong. This is called low-pressure liquid tube. This other is low-pressure gas tube. They are both low-pressure tubes. This is the indoor unit of a split AC. It's what we call the evaporator. This is the outdoor unit of a split AC. The compressor and condenser turn gas into liquid. When the pressure is reduced, cooled liquid refrigerant will travel back indoors. When we browse AC products, we'll find HVAC and AC with inverter compressors. This device here is a 4-way valve with which the AC can be used as a heater. People assume using AC to heat a space may consume more power. Actually, it uses less power than an electric heater. So when we want to buy an AC, the HVAC might be a better choice. It's also a heater in winter. It consumes less power than an electric heater, and the temperature distribution is more even. So when choosing AC, we can consider getting an HVAC, which uses a 4-way valve like this. Earlier, we saw a low-pressure liquid tube. The other is low-pressure gas tube. The viewing windows do not exist in normal AC units. We put them here for trainees to see the liquid refrigerant inside. This is cooled liquid refrigerant. It passes through here, absorbs heat in the room, and returns in a state of gas. For training purposes, we connect the tubes to manometers, one for the gas and one for the liquid. The readings should be close. This is to give you a better idea of the refrigerant in a liquid state and in a gas state. So this is the low-pressure liquid tube. The reading is 16.5 degrees. It's a huge space where we film. So the refrigerant is usually warmer. Inside a real AC, to reach the set temperature, the reading would be around 5 degrees, so that the temperature in the room would be cooler. This reading shows inside the tube how cold the liquid refrigerant is. The air goes in here and comes out here after it's cooled down. I have explained how ACs work. Next, I will talk about refrigerants. Refrigeration and air conditioning are faced with many issues concerning refrigerants. Issues such as the environment, power efficiency, and safety. We've moved from R22 to R410A to R32. R32 is currently used in split AC units. The use of refrigerants has evolved. R22, for example, would deplete the ozone layer and cause the greenhouse effect. It contributed to climate change issues. A few years ago, the use of R410A was encouraged, but for R40A, let's look here. Its life cycle climate performance is poor, meaning it adversely affects the environment. So it has gradually phased out. Currently, the most widely used is R32, which is environmentally friendly and energy saving. Its only weakness, as this red label suggests, is flammability. That is why professional training is required, because the refrigerant in use today is not entirely safe. Without professional training, as you may have heard in the news, AC installation could lead to explosion when technicians know little of the system. They might leave some valve closed or connect tubes without proper protection. That may cause danger. As to refrigerants, here we see different refrigerants will reach certain temperature under certain pressure. As I mentioned earlier, We know why it's cooler here, why it's warmer here, and how much pressure is needed to reach the set temperature. How to control temperature by applying pressure. It's easy to get from retailers or the internet. A refrigerant pressure temperature chart. As you can see here, to reach 6 degrees, we must reduce the pressure to around 0.981 at the capillary tube. That's the pressure. If you want the condenser to pressurize and release heat to turn it into liquid, the pressure should maintain at around 3 MPa. That's about it. It varies from one refrigerant to another. This is R32. This is R410A. When it's turned upside down, like this, the liquid depressurizes and becomes gas. It will begin to boil. We saw the liquid through the viewing window. But when it's upside down, the liquid is no longer there. This means the temperature will go down. Let's try turning it upside down. It's in a liquid state. We'll show you how cold the liquid will be. Let's see, it's colder than minus 65 degrees. It's important that when you handle AC units and the AC systems, if the liquid refrigerant spills, you must wear cold-proof gloves. Eyes are super important. Make sure to put on your goggles. Not glasses, goggles. So I want to remind you, when you handle these systems, don't take the cold liquid lightly. We've mentioned temperature versus pressure and heat removal. Let's quickly go through temperature and the units used. In the metric system, temperature is measured in Celsius. Celsius is a term often heard in weather forecasts, but it's different in other countries. Some countries use Fahrenheit. How to convert from Celsius to Fahrenheit? Just multiply Celsius by 1.8 and plus 32. Let me give you an example. What's 0 degrees Celsius in Fahrenheit? 0 multiplies 1.8 is 0 plus 32. So it's 32 degrees Fahrenheit. To convert Fahrenheit to Celsius, deduct 32 and divide it by 1.8. That's the conversion formula. Or also, you can find a conversion chart online. Let me explain how this works. I want you to know that 0 degrees Celsius is the temperature at which water begins to freeze at 1 atm. When we heat the water until it boils, the boiling temperature is 100 degrees Celsius. These are the rules. Remember, they are set at 1 atm. Let's move on to pressure. There are the metric, imperial, and SI systems. We've seen the pressure temperature chart showing their correlation. Let's take a look at standard air pressure. What does ATM mean? 1 atm is the air pressure at sea level. It's different in the mountains, where the pressure is lower. So the air pressure at sea level is defined as 1 atm. In the metric system, it's 1.033 kgf per square centimeter. In the imperial system, it's 14.7 pounds per square inch. We rarely use this measurement. Most technicians use PSI, pound per square inch. It's better to be clear. We use the SI system to follow global standards. Many instruments, devices, and manometers show this unit. It's called bar. 1 atm equals to 1.013 bar. 1 atm is 101.325 kilopascal. Many manometers today, including these units, for easy conversions. Let's move on to heat removal. It's important to know about cooling capacity when we buy an AC. Take this one for example, is 2.5 kilowatt. What does that mean here? It means 2.5 kilowatt of heat is removed from the room per hour. 2.5 kilowatt equals to how much 1,000 calories? A 1-ton AC has a cooling capacity of 3.516 kilowatt. This is a 1-ton AC. This 2.5 kilowatt on this nameplate is often referred to as 1 ton on the market, but it's actually about 0.8 ton. A 1 ton is 3.516 kilowatt, so when we buy an AC, we must read the nameplate. An AC of 1 ton can remove heat of 3,024 kilocalorie from the room per hour. We need to learn about heat removal when we learn installation of AC. We should also know about these basic rules. Next, I will talk about the nameplate on an AC unit. It's on the side of the unit. When the technicians arrive with a new AC and opens the box, there will be a nameplate on both the outdoor and indoor units. You must learn about the nameplates. Let me quickly go through the content. Some items are often neglected, like this one, type T1. T1 means for temporary climate. If you use this unit in the Middle East, it wouldn't work because it's very hot. Cooling efficiency will be low. It wouldn't work. When an AC unit is made, T1 is meant for temperate climate, when the air temperature is between 18 and 43 degrees. Now let's take a look at IPX0. As the waterproof rating, the AC's rating is 4. Light water splashes. Dustproof rating? None. No test for that. It could be lower than 0. It wasn't tested. We must read these ratings. Cell phones with ratings at IPX5 and 6 excel at waterproofing and dustproofing. These 4 labels are very important. As I mentioned earlier, electricity safety is very important, and product inspection. This label here is the CNS mark, issued by the government. The second label is product safety mark. Every AC unit will have the following 2 labels. One is energy label. The other is green mark. Next, let's look at a label that's on every AC, the energy efficiency label. On the label, there are 5 grades from 1 to 5. Grade 1 means highest efficiency. It's also the most expensive. From grade 1 upwards, the less efficient, the lower the price. The efficiency is graded on criteria, which can be found online. AC's energy efficiency is graded from 1 to 5. The government is promoting the CSPF label. We used the EER label on AC units. Now we're using the CSPF label. CSPF is a result of dividing seasonal cooling capacity by seasonal energy consumption. What does it mean? EER focuses on only one criterion. Now the AC is tested on multiple criteria because it will be used during various seasons. So this is the formula we use to get the CSPF. What does it mean? The higher the better. 6.83 means grade 1. According to the national standards, in a split AC unit, 5.93 can rank as grade 1. 6.83 and 5.93 are both grade 1. 5.94 is also grade 1. 7 is also grade 1. You must check it. It's marked here, not easy to see. Most people only notice the grades. Now some may wonder, ACs that are more expensive are more energy efficient. Cheaper ACs are less energy efficient. If I spend extra $10,000, should I choose the former or the latter? If it runs for a long period of time, such as in the living room or in a store, and is often in use, you should buy a more efficient AC for better value. If it runs 1 hour per day, choose a cheaper AC. Of course, the government would encourage people to choose the efficient type, but consumers care more about the cost. Next, simple calculation of AC cooling load. It will tell us the tonnage suitable for our need. We can always consult a technician, but we should also have some idea about the tonnage of ACs. This one is 500 kcal per ping, suitable for houses and apartments. But for an office, we should choose 600 kcal per ping. Also places like theaters and restaurants. How much is 1 ping? Just multiply length by width of a space. 1 ping equals to 3.3 square meters. Take this room for example. If we have a room of 6 pings, and the cooling capacity is 500 kcal per ping, for 6 pings, it will be 3,000. So we need a capacity of 3,000 kcal. That's about 1 ton. For a residence, 300 kcal cooling capacity for 6 pings. So 3,000 kcal is close to 3.5 kilowatt. It's what we call 1 ton. That's for a normal room. For rooms facing the west, or on rooftops, multiply 500 by 1.3, by 1.3 to 1.5. This will ensure that you have sufficient cooling capacity. We must know this when we choose AC. This is the structure of a split AC. You need to know this. Many people talk about how to maintain and clean the ACs. Both outdoor and indoor units matter. Knowing the structure, we'll know that when dust enters, it will stick to the filter. Some dust will go through the filter and stick on the heat sink. When dust stays for long, plus moisture, when the AC is not on for 5 or 6 days, molds may grow here. When mold is in here, the air will have odor. So we must have the ACs cleaned frequently. Of course, dust will gradually gather here and make the AC dirty. It needs to be cleaned. The AC should keep the room cool and keep us healthy. These are indoor units. Wall-mounted units are popular and most common on the market. But sometimes, the hidden type is more suitable for the interior design of your living room. This is the air outlet. This is a suspension type. It's suspended here, much better looking. We often see this type in convenience stores. It's called ceiling cassette. They work on the same principles. They are all evaporators in different shapes and forms. Portable ACs are suitable for smaller space. They're portable, so some campers will use them. This is a column AC. It's a floor mounted for indoor use. This is HVAC. On this diagram, this is a compressor, the evaporator, and the condenser. Then there's a conversion. As I explained earlier, refrigerant flow through. It's warmer here. After the conversion, the cooled refrigerant returns to the compressor. If I want to heat up a cold room, I'll turn this on. It will move this way. When refrigerant is pumped in, it will come here. The refrigerant flows here towards the indoor unit, and it will send out warm air. The AC becomes a heater. With this device here, cooling is converted to heating. In addition to this, heat pump water heaters stores the heat inside the tank. Our hot water is almost free because heat comes from AC. This is called heat recycling. Another function that combines cooling and heating is found in dehumidifiers. In this scenario, a dehumidifier also works as a heat pump laundry dryer. We use water heater and laundry dryer nearly every day. This is a good application. You may wonder if inverter types use less power. Take a look at this chart. Suppose we use a traditional unit and set the temperature at 25 or 26 degrees. When the temperature reaches 26 degrees, it will stop. After that, it will start again at 28 degrees. The temperature changes between 26 and 28 degrees, so you'll feel cold and warm intermittently. It stops and restarts more frequently, so it'll consume more power. Inverter units distributes temperature more evenly. When it's set at 26 degrees, the temperature control is within plus and minus 1. The compressor never stops running. You may think it will consume more power, but when the frequency drops, power consumption will drop by a factor of 3, so it's relatively power saving. Most people choose inverter HVAC units. As they become popular, they become cheaper. So when choosing an AC, this is a good option. Installation and maintenance. There are 20 steps to go through. This is an indoor AC unit. We'll show you how to explain installation to your client so that they won't feel the AC is tilted. There should be enough space for maintenance and air return. It's the same with outdoor units. Problems are emerging. They are installed at dangerous spots or when there's no suitable space. We might install them in a makeshift space. This will cause difficulties for future maintenance. Let's go through these steps with demonstrations. First, on-site inspection. We evaluate the suitable tonnage, the types to use, and the client's needs. Sufficient communication is important. Secondly, quotation. When we install an AC, we must have all the tools ready. Tools such as a simple vacuum pump, tube connector, and an electric drill. We must have the basic tools ready. It's also important to allocate tasks and explain safety. Safety guidelines must be reiterated every day. Every summer, AC installation causes FFH casualties. Many technicians get injured, so safety guidelines must be reiterated. On site, be careful when you open the box. Clear and cover the space as needed. Don't damage or smudge the client's possessions when you install or repair an AC at the client's place. Next, we'll cut a hole in the wall, then we'll install the indoor and outdoor frames. Make sure the frames are level and secured. Next, we'll cut the refrigerant pipes. Secure them in the pipe covering along with the other wires. Then, refrigerant pipes and the drainage pipes must be properly arranged and secured. Make sure they are properly bundled. Next, fix the copper pipes and connect them securely. Then, we need to vacuum. This step is crucial. In order to save space, many people avoid using this method. They use the refrigerant from the outdoor unit to push out the indoor unit's air. You will never push out all the air, so it's best to insist that your installers use the vacuuming method. Another important thing is whether there are any leaks in the pipes. We must check the pressure. We usually use a mechanical device. For our demonstration today, we'll use a digital one, as it provides a clear indicator for leak checks. Next, we'll clean up, connect the pipes, and test the drainage. Then we'll open the refrigerant valve on the outdoor unit, so the refrigerant will flow into the indoor unit. We'll perform a leak check. If there's no issues with the indoor unit, we'll proceed with insulation for the pipes. Then we'll open the low-pressure gas valve, the low-pressure liquid valve. With these valves open, the system will be operational. Next, we'll turn on the AC, operate it, put down records, and test if functions are working. Functional testing includes many processes, checking for vibrations, noises, and water leakage. Lastly, it's essential to remember that when installing split-system air conditioners, grounding is of utmost importance. Both the indoor and outdoor units must be grounded. Don't skip this. Frequently, due to improper grounding, repair personnel get shocked. So ensure proper grounding. The final step in the process, collecting payment. These are all the steps for AC installation. We can see in the demonstration. Clear the site and unbox. When AC arrives, most importantly when you're installing, the area must be cushioned. For the split-type air conditioner's indoor unit, this is the panel. If you accidentally scratch the panel on the ground, the customer might think that you should replace it with a new one. When we go to a customer's place to install an AC, or when you reinstall an AC, important items must be moved away first, or when moving or pulling pipes, you could accidentally break something. Additionally, the entire wall must be cleaned after installation. We'll use protective tape for some areas, and we also call it a masking tape. Now, after we take the AC to the customers, we need to open it. This is what we call unboxing. Once opened, we have the outdoor and indoor units. When placing an outdoor unit, be careful not to scratch it. So you can put it on the original box it came in. You can put it like this. In addition to that, you should check the pipes to see if there's pressure. If there's no pressure or if it's very low, most people do this by experience. It means there's a leak in the system. In that case, don't install it. Even if you installed it, the refrigerant will leak. You also need to check if all items are present. When AC is installed, we need to insulate the pipes. We use it to insulate the connecting pipes, as well as for the drainage. And there's a recessed area here, so we can see some space here. If the pipes need to go that way, then we should cut it in that direction. Cutting a wrong hole will look bad. So if the pipes need to go that way, cut in that direction. If they need to go in this direction, cut in this direction. Similarly, for the drainage pipe, you can attach the drainage pipe here. You can attach it here, move the pipe here. These are what we need to check when unboxing indoor unit of a split-type AC. Alright, next what we're looking at is the outdoor unit. The outdoor comes with a label, this nameplate. So check if these specifications match, because you quoted the customer using these specifications. If the product doesn't match the specifications, the customer thinks it's a scam. Next, check the appearance. Everything should be intact. Also check the fins. Sometimes production and packaging can cause damage. When unboxing, we must check these things. The place to install the indoor unit must be communicated well with your customer. The customer may know where they want it installed, but we should tell them what they don't know. First, the installation must be secure, it doesn't cause vibrations. Next, it should be easy to remove and clean the filter. There should be enough workspace. Customers usually don't have ideas about that. For proper installation, you must make sure there are no obstructions near the supply vent and return vent. Otherwise, it can lead to short-cycling AC. To fixate an indoor unit, we must first center it. When centered, we'll use drill bits and screw for high tensile materials for fixation. We'll do an on-site demonstration. We need to measure its dimensions. Now take this wall as an example. How can we place an AC in the center? So we measure here is 82 centimeters. To center it, we'll attach the indoor unit's mounting bracket onto the wall first. There's a center point on this wall. You must align the bracket with the center point. There's a marking for the center point here. You can move the bracket up or down or hang it here. Remember, the bracket must be level or the AC will tilt after installation. So we'll use a long level to secure it like this. You can see that it's level now. Now we can tighten the high tensile screws. Always be careful. Do not let it tilt. Don't use nylon wall plugs. Just screw directly into the wall. We don't need to tighten them completely. We'll do so after everything is in place, because sometimes you will need to adjust the position. We'll test again at the end. Don't just use one screw. You should use around 5 to 6 screws to secure the bracket firmly so it won't wobble during use. Finally, place a level on the bracket and make sure it's level. We want to make it level. This is how you fixate an outdoor unit. Make sure you communicate well with the customer about this. For the outdoor unit's mounting bracket, we have H-shape, L-shape, and A-shape brackets. This is what we call an H-shape bracket. Generally, when we install an outdoor unit for customers, we use H-shape brackets as they're more sturdy. Later, we'll demonstrate how to assemble and secure this bracket. Next, we'll show you how to drill the holes. This is an expansion bolt. Sometimes we call it a gecko. This is a 4-groove drill bit. As you can see, this shows how deep you should drill. This is crucial. If it's too deep, it won't hold. If it's too shallow, it won't fit. So at the beginning, tighten this a little bit. Tape it about 0.5 cm to 1 cm from this point. So we'll know how deep to drill. So we've done taping. It should look like this. We'll demonstrate how to screw in the expansion bolts. Just like with our indoor units, aside from being secure, the most importantly, it should be level and well positioned. We must ensure there's enough space for proper ventilation. We don't want hot air blow out and get blocked by obstacles. Now we'll screw in the expansion bolts. Let's draw this line. Then mark for this hole. When using a drill, make sure it's perpendicular to the wall. Don't apply too much force. It must be vertical when drilling, so that the expansion bolt can go in straight. Just drill it into the marked area. Good. This indicates dust inside, but since we drilled rather deep, the dust will be trapped inside, so we'll now hammer it in. If you hammer it like this, you might flatten this area. Then the nut won't come out, so we'll adjust this one slightly to avoid hitting the screw directly when hammering. We'll hammer the nut instead. Alright, now we'll hammer it in. After that, let's tighten it. When it's tightened, you will see something similar to this. The bolt will expand inside the wall. That's why it's called expansion bolt. It needs to be tightened to expand. Once expanded, we can place the heavy outdoor unit on it so it can support weight like this. It needs to be tightened to expand. After it expands, it will be stuck in the wall. You won't be able to remove it. If you don't want it there, you will have to cut it off. Otherwise, it won't come out because it's fully expanded inside. When hammered properly, it can support the weight of an AC. Now we'll attach the brackets. Make sure they are vertical and level. First, secure the knot. For easy future removals, try to secure it outside. If you secure it inside, it'll be hard to remove in the future. So when installing the support bracket, we call it an outdoor unit bracket. Or when installing the screws or the expansion bolts we just mentioned, choose stainless steel, because rust can make it hard to remove the AC in the future. Make sure it's level. This should be level, or the AC will tilt. Now we lift the outdoor unit onto the mounting bracket. Secure this part of the bracket. Make sure it's secured. Remember to level it. Being level isn't enough. You want to make sure it's level after mounting. We need to make it firmly secured. We used expansion bolts just now. 4 to 6 bolts will be enough. This is how we secure the outdoor unit. Next, we'll connect the pipes. These are coated copper pipes. The pipes are 1/4 inches and 3/8 inches wide with a length of 30 meters. So the length of the pipes is 30 meters. When pulling these pipes, be careful. Don't pull the entire thing out like this. Take them out this way. When you do that, don't pull them from here. We want to keep the pipes straight, so we unroll the pipes to straighten them. They won't be straight if you simply pull them. After making them straight, measure the length of the pipes needed from the indoor unit to the outdoor unit. Now we'll unroll it. We'll cut the pipes to make the flare openings. Now we'll demonstrate how to cut the pipes. This is a pipe cutter. Now we'll cut the pipe. After cutting, the edge of the pipe will be recessed. We call this burr. We'll remove the burr. When you remove the burr, don't do it like this. If you do it like this, copper shavings might get inside the pipe and could block the system. When scraping off the burr, make sure it's facing down. Then we scrape off the burr. After that, we need to make the flare openings. This is a flaring tool. When this flaring tool reaches the end, it will make a click sound, indicating that it's done. At this point, we should remove it. Be careful when making the flared opening. If it's not done properly, the refrigerant can leak. Our system contains internal pressure, so refrigerant can leak from here. That's why when we buy an AC, after using it for some time, the refrigerant will be gone. It's usually because this part isn't done properly. If done properly, the flared opening will fit the jointer. Like this one here, the flared opening is too small. The area it covers will be smaller, making it prone to leaks. Sometimes the opening cracks. Like this one, we tighten it too much, and this area cracked. In this case, this opening should not be used anymore. If you use it, the refrigerant will leak. So when you make the flare opening, it can't be too big. This one is too big. It can't be too big. It can't be too small either, or it may crack or distort. So when making flare openings like this, we need training. We need to be skilled, quick, and precise. This is just right. Now this is what we call a nut. This is a nut, we'll tighten it. So when installing the indoor units and outdoor units, we need 2 connections. This is the service valve of the outdoor unit. Let me show you how to secure it. First, we'll screw this nut in. After tightening it, we need to wiggle this pipe slightly to center it. Then we'll use a tool to tighten it further. This is how we secure the outdoor unit. Next, we'll bend the pipes. As you can see, these are copper pipes. If you bend them and they get flattened, you want to notice it. So sometimes they're already flattened. Flatten means you can't bend them back. They won't return to the original shape. If the pipes are flattened, it could be a problem. We need special tools to bend them back, but they won't return to the same shape as before. So when bending the pipes, experience is necessary. The radius can't be too small. If it's too small, the pipe will get flattened. Also, the quality of these copper pipes can be poor. If they're too thin, they can easily flatten when bending. Okay, once it's done, we'll secure them. To secure them, we might use an adjustable wrench, but you may not know if it's tightened correctly or too tightly. That's why we use a torque wrench. This is a torque wrench. We'll use it to tighten it. When tightened properly, it will make a click sound. Don't do it wrong. Alright, it's done. Once it's tightened, we'll open the refrigerant valve here. Because during installation, the indoor unit ran out of refrigerant, so we'll open the valve to allow refrigerant from the outdoor unit to flow into the indoor unit and then back out. The two flared openings connected earlier and the two openings behind the indoor unit need to be checked for leaks. So we'll open the refrigerant valve. We do this to check for leaks. We'll check for leaks using soapy water. When we check for leaks, if there's a leak, you will see bubbles. This is how we check for leaks. If the leaks are very small or difficult to detect in some spaces, you can use an electronic leak detector. If there are leaks, it will make a rapid sound. Alright, if it gives a rapid sound, it means there's a leak. This is what we set. Aside from using soapy water for leak detection, we can also use an electronic leak detector. Now we need to connect the wires between the indoor and outdoor units. This one controls the other, and this is the power supply from the outdoor unit. It has a power supply here, don't do it wrong. The L1 and L2 are the power supply. They're numbered 1, 2, 3, and red, white, and black wires. We need to wire our indoor unit accordingly. That is, match the red, white, and black wires. Each should match with its counterpart. Incorrect connection can cause sparks. That's very important. As you can see, there is no ground wire here. So we should add one from this wire to ground the unit. The outdoor unit must have proper ground connection to prevent electrical hazard during maintenance, in case where terminal connectors aren't used. Over time, disconnection may occur. They can turn dark or detach. If the ground wire is green, we should use O-type terminal connectors to secure it properly to prevent detachment and make sure it's secure. There are some incorrect examples here. This one has very long stripped wire. It's too long. When the AC operates, the wire can contact the adjacent wires and lead to short circuit. In this case, this wire protrudes. It sticks out. This is the correct way. It's pressed correctly on this side. Pressing it at the back side like this is incorrect. This wire is stripped to the extent that only one thread is left. Just one. With just one thread, when the large current flows through it, it can melt. Or there can be poor contacts that generate heat. These are crucial points for wiring. The wires we used earlier are connected based on color or numbering. Now let's look at the no fuse breaker. If the amperage is too low, the breaker gets tripped immediately. If the amperage is too high, it doesn't get tripped even if the wire is burnt. There are regulations for this, and there are certain requirements. These NFB is rated at 15 amps. This is the so-called trip current. How we choose the trip current depends on the label on the compressor. The label indicates the power consumption in ampere. Multiply by 1.5 to 2.5 to determine the trip current for the NFB. Next, we need to pay attention to this. There's a dedicated power outlet for the AC. This dedicated power outlet always has a ground wire, and the ground wire must be connected. Like this one is not connected. Sometimes on a machine, there's a symbol like this. The symbol means you should make a ground connection. This is the symbol for ground connection. Next, we need to install the drain pipe. When installing the drain pipe, we use a transparent pipe. Sometimes when we install it, it gets dented. It can get deformed. With the dent, water won't drain properly. It can overflow from our indoor unit into the room. So it's best to use a more resilient type of pipe like this so it won't flatten. Alright, next we need to create a trap to trap water. When connecting the drain pipe to the ditch, some odor can get into the indoor unit from the ditch. This is why we usually create a trap. Note that traps are not always necessary for AC installation. A trap should only be used when AC is connected to the ditch. If not, it's best not to create one, because if the AC is not used for a long time, scale can accumulate. The next time you turn on the split-type AC, the water won't drain. Then it will fill up and overflow into the room from the indoor unit, like this one. We need to drain the water forcefully. We call it a drain pump. A drain line is like this. If it goes down, it's easy to drain the water. But if it goes up, you will need the drain pump to pump the water out. This is how the pipes of the split-type AC are arranged during installation. These are the rear copper pipes and the control wires and power wires and the drain pipes. So inside here, there are copper pipes, water pipes, and wire, all installed in the drainage pipe. After we've installed everything, we need to conduct a leak detection and perform a test run. As mentioned earlier, there is the outdoor unit, and during installation, air can get inside, so we need to vacuum it. For vacuuming, we need several tools. One of them is a compound pressure gauge, just like this one. Here's a digital vacuum gauge. With this, we can accurately check for leaks. This is our vacuum pump. So with these three tools, we can perform vacuuming. Now let's start the vacuuming process. We place the pipe here and use the tool to monitor. When we've finished vacuuming, we need to check the pressure. If there is a pressure increase, it means we have a leak in the system. There shouldn't be any pressure increase in this process, so this part should be pressure-free. After checking if everything's fine, we'll open these two valves. We'll open this valve and this valve as well. At this point, the refrigerant will flow to the indoor unit. Now we'll do the leak detection. Now let's switch it on. If there is insufficient refrigerant, we need to add a refrigerant. We use the remote control to start it up. Remember to set the temperature to the lowest and the fan's speed to the highest. Let it continue to run. Meanwhile, we need to check the pressure here. In the summer, the pressure should be around 120 to 130. Right now, it's about 110. This split-type AC shows the low side pressure only. We can conclude that there's a slight shortage of refrigerant. We need to add refrigerant. For this, we need to refer to the manufacturer's manual. For instance, it may say the pipe length would be 5 or 7 meters. If the two units are more than 7 meters apart, it tells you how many grams of refrigerant to add for the extra meter. It depends on the size of your environment. For a set of 1/4 and 3/8 inch pipes, 20 grams per meter is needed. So if it's 10 meters extra, you will need to add nearly 200 grams. This is what we need to add. But how do we add 200 grams of refrigerant into the AC? We need to use an electronic scale. So we use R4108 refrigerant. We use a fixed quantity method. It's an azeotropic refrigerant. We need to turn it upside down. Then the liquid is at the bottom. Filling the AC with liquid ensures more accurate proportions. Now let's add the refrigerant. As I said, if there's not enough, we need to add more. For an inverter split type AC, you must recover all the original refrigerant and use a fixed quantity method to ensure more accurate filling. For inverter AC, just fill to the level until the pressure reaches 120 to 130. This is how we add the refrigerant. After a split type AC is installed, we need to keep operation record, record the data, and in this record, we record figures we observe on the site. Many devices can collect data, then transmit back to the company to be archived. So what do we record? Outdoor temperature. It has to do with the external environment, so we need to measure the outdoor temperature. Next, we measure the indoor temperature. Indoor temperature is close to the return air temperature. We also need to measure that, and the temperature of the supply vent, and the operating current, as well as the low side pressure. All of these should be recorded. This allows us to understand how the split-type AC operates. It serves as a reminder for future maintenance. This is what we record during installation. We need to document the data clearly. Our operating current is displayed here. There's a clamp bond ammeter. We can see the current and low side pressure. Now we'll use a thermometer to measure the temperature at the supply vent. Because there's a slightly less refrigerant in this AC, the temperature is relatively higher. Now we see this operating current. The operating current on the label may say 3 amps, But when the AC is running, it might just be 2 amps. That's because it was measured in a certain environment. The indoor temperature is 27 degrees and outdoor one is 30 degrees. The operating current measured under such condition was put on the nameplate, which was 3 amps. But it might just be 2 amps here. This is probably because our outdoor temperature is lower. So when referring to the label operating current, you need to consider the outdoor temperature. If the outdoor temperature is lower, the heat dissipation would be better and the operating current will be lower. So when we adding refrigerant, say the outdoor temperature is 28 degrees. When you add the refrigerant, don't assume the pressure or operating current will be the same as the figure on the label. Adjustments are needed. Next, we'll discuss the maintenance of the AC's indoor unit. Before maintenance, we must start it up and test its performance. If the unit makes noises, or the refrigerant has been filled, there might be some issues after maintenance, so we need to start it and test it. Then we'll turn off power and remove the panel cover. When you do that, be aware there's a specific direction for removal. Be careful not to break the inside clips when you remove the panel. The screws have different length. You must pay attention to that. Make sure the screws are placed correctly. And don't leave the screws around. Sometimes when you leave them on the floor, you step on them and break them. And then we remove the filter. If it's dirty, we should clean it. Next, we remove this cover. There are 2 clips on the cover that needs to be detached first, then lifted from the top. There's something in the middle that needs to be pulled up with force. Be careful not to break it. Finally, we remove the entire outer casing. Again, don't throw it around. Now we need to do some cleaning and maintenance. This is the equipment to clean the indoor unit. There are 2 types of sinks available, the so-called hard sink, and there's another one made of canvas. It depends on where the AC is. After settling, we will hang it here. When cleaning, it's important to cover this area so that water doesn't go into the circuits and the board. This is a very important step in the cleaning. Then, this wall here may have been painted nicely, so before you spray the cleaning solution, cover the wall up with the protective tape. Then the cleaning solution we've just talked about. You should never use strong acid to clean the AC. Now we spray on it. Spray it from the top. We can use a pressure washer. There are specific ones for acidic solutions, and their spray heads won't be corroded by strong acids. This is how we clean the indoor unit. After you spray the cleaning solution, let it soak for a while to allow for a chemical reaction. Make sure you clean it thoroughly. Now we'll use water to clean it. The unit must be cleaned thoroughly so that there's no acid residue. If the customer turns on the AC when there's residue, the residual acid might get indoor. So when we use cleaning solutions, they must be of good quality. The maintenance must be thorough. Now we move on to the indoor unit's blower, which also requires maintenance. This is the actual condition. This is the blower. Since there's a lot of dust on it, it must be cleaned. This is a heat exchanger, and it's quite dirty. After cleaning, it will be much cleaner. Here we have splitters in the panel, and they're usually quite dirty as well. After cleaning, they look like this. Make sure to wipe them dry. This is a filter. The user didn't clean it for a very long time. This is a demonstration of the cleaning process. This is the cleaning process for an indoor unit of a split type AC. Finally, for the entire system, when you clean or install it, the most important step is to check again before finishing to prevent any loose screws that haven't been secured or loose covers that could cause leaks. There are some various checks and operational data to be recorded here. We've talked about them. First, we check the indoor unit's installation. We check if it's level, grounded. if pipes coverings are installed, and if the pipe coverings are level. If the coverings are tilted, it looks bad. Then we check the thickness and diameter of the drain pipes. Remember that the indoor unit's drain should be tested. We talked about the system handling earlier. I have demonstrated vacuum for at least 20 minutes. For pressure testing, we need 10 minutes to ensure there's no increase with the checking device. This is the inspection of the indoor unit. Many items here just like the outdoor unit. We check the distance from the wall, and we check the piping. Now this is the entire checking process for piping. Whether you are working as an installer or a supervisor, you must have a solid understanding of every aspect of the job, such as pipe arrangement, system handling, drain pipe installation, wiring system operation, refrigerant judgment, and overall quality of the task. You must perform thorough checks. This unit here is used to train people to identify problems. You can see that for this indoor unit, the connectors are not insulated. This is a huge mistake. Water may leak from here. Then it looks bad when pipes are not level. The drain pipe goes up here. This can cause drainage issues. Next, let's take a look at the outdoor unit. It's tilted and not secured. And during installation, regular nuts and bolts are not used. Instead, self-tapping screws were used and caused the tilting. There are many things to check, such as tilting. These are all among the checklist when you finish installing a split-type AC. As you can see in the video, from unpacking the air conditioner to the completion of installation and future maintenance, all these aspects require professional knowledge and technical expertise. As you can see, many disputes regarding installation can be found on the internet or in the media. The abilities to communicate and describe the issues are essential for people engaging in AC installation. In addition to these three abilities, what is also necessary is your passion for the job. You must be enthusiastic and responsible. Next, you must be sincere. These are essential qualities for someone to become a professional. Lastly, I'd like to share with you that if you come to a training center like ours, you might think that learning this knowledge can be difficult. Through the training in this video and at the center, you can easily acquire professional skills and the core abilities I mentioned earlier, that is, the abilities to communicate and negotiate. We should let the professionals handle the tasks. Although after watching this video, you may want to try it at home, but you need some experience first. Otherwise, during installation, it might cause damage to the equipment.